Okay, so I think that is a good time to start, and other students will come in later. So we are still at module 7, and today we try to wrap it up and move on to module 8 right away. So let me start the class notes. So we have module 7 about supply chain. Oh, I'm sorry, about project management. For the continuity of our discussion, let me briefly review what we did earlier. So in module 7, we start with the concept of the project, right? The project is a one-off initiative where we have multiple tasks and activities. And then we need to coordinate among those tasks and activities, right? So that the whole initiative can be completed on time and within budget. So that's the coordination, right, is essential in a project. And then to manage our project, we have to do the following. We have to do defining and then planning, controlling, and we have to close it, right? So these are the main activity in project management. So next, we learn about the critical path method. Or CPM. Right. So in this critical path method topic, we went through the wedding example. We learned about 4 methods to find the critical path, right? And along the ways, we also find the slack times of the non-CPI activities so that we can schedule our project, right? So we learn about the critical paths. And then together with that, we learn about the slack times. So that we can do, we can schedule our project. And we say we schedule our project, it means that we schedule the individual activities, right? If it is a critical path activities, then we have to keep it very tight together. If it is a non-critical path activity, we can kind of move them around a little bit without impacting our project schedule, right? And then so those are the big topics that we talked about earlier, right? And today, let's move on to the next topic about crashing a project. Okay, that sounds like crashing a party, but actually not, right? Crashing a project just means that we try to cut down the completion time of the project. Right, sometimes we need to meet an early deadline, something like that. So we have to cut out the completion time of the project and meet with that new deadline, right? The question is how to cut down the completion time. So here we only discuss the conceptual methods on how to do this without any calculation. For example, the first method is if we start things as early as possible. Then we can kind of control the completion time of the project, right? And if we do not start things as early as possible, we might delay the CP activities. Then the whole project will take more time to be completed, right? So starting things as early as possible is one way to control the completion time, or in some way is a way to cut out the completion time. The second conceptual method is we need to manage our scope, the project scope, so that we can stay within the original schedule. If you look at the residential construction industry, for example, at first they estimate that they're going to take 1 year to complete the house, right? But then in the reality, it might go to 1.5 years or even 2 years. Why so? Because the homeowners, they decide that they want to do more and more, right? So because of the changes or the expansion in the scope, then the completion time will be longer. So in commercial construction, right, if you want to complete the project on time, then you have to think hard about the scope first. What scope we want to do first, make a good estimate of it, so that we don't have to change the schedule later on, right? So managing the scope is another way to control the completion time, or the sometimes is to cut down the completion time. Method number 3 is called we overlap the critical path activities. Let me give you a very simple example to illustrate this concept. So the critical activities normally are kind of chained together, right? One is done and then we move on to the next one. But sometimes we can overlap them. And as an example, for example, we need to redo the texture in our on the walls of the 3 rooms in our house, right? So, for example, somebody wants to have the orange peel texture on the wall. Then, first of all, the workers will have to redo the texture. And then after that, they will need to repaint the whole wall, right? So originally, we can think about the schedule of the project as the following. First of all, the workers, some worker number 1, for example, will need to redo the texture on the wall, right? And after all the texture, all the walls are done, then another workers will come in and do the paint, right? So originally, it's going to take this much to complete the project, the 3-room redo, the texture redo of the 3 rooms. Right? That's how long it takes to complete the project. But if we rethink about it, there's another way to do it. So, for example, the first worker finished the new texture in the first room, and texture, and that worker moves on to the second room. Then the second worker will come in right away and paint the first room, right? And then when the first worker is done with the texture of the second room, the second worker will paint the second room. And then they will do that for the third room, right? So relative to done before, the picture will look like the following. The texture activities will take that long time as before, but we do not wait until all the textures are done before we paint it, right? In this case, we might start the painting earlier than before. So with that, now the new project completion time is this, rather than like before, right? So in a sense, we really cut out the project completion time. We're crashing a project right there, right? By overlapping the CP activities. So as a project manager, right, normally we would schedule one after the other. But then if we think hard, then we might find a way to overlap them. And by doing that, we can cut down the completion time of the project. Method number 4 is now we even crush the activity times themselves. Right? So crush the activity times. For example, to redo the texture of this room, normally it takes 2 days, right? But then if they find a better way, they only do that in 1 day or 1 day and a half, right? So we call that as crushing the activity times. We cut down the completion time of each of the activities, especially the one on the critical path, right? Okay, so in that case, it's going to take 2 more days for us to do the crushing the activity times with all of the calculation, right? We will not have time, and that method is not required. So I will not cover that technical topic here. I recommend you to read more about this in module 7, slide 41 through 44. It's about questioning the activity times. It's quite a technical work here to know how to question activity times. So in the exam, I will not ask you how to question activity times, right? We just talk about these at the conceptual level. Okay, so that's the next topic, right? Let me recap. In module 7, we talk about what a project is, what a project is, and then what are the activities of project management, and then how to find the critical path, how to find the select times, right? And then we can factor those into the scheduling of the project. And then the next topic that we just talked about is questioning a project, right? Either we start things as early as possible, or we manage the scope so that we will not blow up the time or the activities that we have to do for the project. And then method number 3 here is we try to overlap the critical path activities to cut down the project completion time. Method number 4 is now for each of the activity, right? We can even cut down the time to finish each activity. And that will help us to crush the project too. Okay, so we are done with that, and I would like to move on to the last topic of module 7. So in the last topic of module 7, we will deal with projects with time uncertainty. In the critical path method, we make a crucial assumption that the completion time of each activity is fixed, right? But in the reality, maybe we have to deal with activities where the time is not fixed. So to do that, I would like to work with you on a very simple example. A simple project. It's not in the slide, so we only have here in the class notes. So as usual, we would depict or describe a project with the following table. In the first column, we have the IDs. right? We have the activities themselves. So this is a very simple project. We only have A, B, and C. It's very similar to one of the connect questions that we did some time ago. In the second column, we have the immediate predecessors, right? Or in other words, we want to know what comes right before the activities. Right before it, we don't have anything. So A can be started right away. Right before B, we have A. Right before C, we also have A. In other words, A needs to be done before we start B and C. The third column tells us the completion times. Right? How long to finish each activity? So in this example, right, we can finish A after 2 weeks for sure. So this for sure means that we are going back to the assumption of the critical path method, right? And then for C, it takes 5 weeks for sure. Again, that's the assumption of the critical path method. But for B, right, now we have the time uncertainty here. B can either take 4 weeks to be finished with the probability of 0.7, right, or 70% chance that we can finish A. 70% chance that we can finish B after 4 weeks, right? Or we would finish B after 6 weeks with the probability of 0.3. Or 30% chance. So that's where we can find the time uncertainty in this project, right? Activity A is fixed, activity C also fixed, but activity B, there are 2 possibilities, either 4 weeks or 6 weeks with some probabilities, right? So we do not know for sure anymore. So here is the question of this example. What is the expected completion time of this project? Right? So expected means average. Right? So assume that we repeat these projects multiple times. Then on average, how long it takes to complete the project. Right? So that's the question here. Of course, a project is not repeated. Normally it is a one-off, right? But here we try to kind of calculate how long it's going to take on average to finish the project. To do that, we should realize or should notice the following 2 possibilities. Or 2 scenarios. In the first scenario, we can finish A after 2 weeks, finish B after 4, C after 5 weeks, right? And that might happen with the probability of P1 70% chance. Or in the second scenario, we finish A after 2 weeks, finish B after 6 weeks, and C after 5 weeks, right? The A and C do not change because they have fixed completion time, but B has a time uncertainty, so either 4 or 6 weeks. And this might happen with a probability of 0.3. All right, so the idea here is the following. We're going to look at the first scenario, calculate how long it takes. And then look at the second scenario and calculate how long it takes. And then we average it over between the two scenarios, right? Then we're going to find the average completion time of the project. All right, so to be more specific, let's look at the two scenarios. Again, in scenario 1, A will be finished after 2 weeks, B after 4, C after 5 weeks, right? And this will happen with the probability P1 0.7. The probability is important because it tells us we can quantify the uncertainty of the project. So in this case, right, in the first scenario here, how long does it take to complete the project? So to do that, we draw as usual, right? We go back to the critical path method. We draw the project Nguyen network like this. So A is required before B, A is also required before C, and that's it, right? It's a very simple project. So A takes 2 weeks, B takes 4, C takes 5 weeks. I would like to ask the whole class, in this scenario number 1, which one is a critical path? Remember, we need to know the critical path because we want to know how long it takes to complete the project, right? So in this first scenario, which one is a critical path? Please feel free to share in the chat window. I have that from Fallon and Christopher already. Do other students agree with Fallon and Christopher? Do you also have the critical path as AC? Good. Michael also got the same thing. Good. Yeah, and Jose and Mike, oh yeah, that's right. So in this case, there are only 2 possible pathways through the project, either A, B, or AC, right? And we notice that AC is our critical path because it is the longer between the 2 possible critical paths. I mean, between the 2 pathways. All right, so our critical path here in this first scenario is going to be AC. AB is 6 weeks, AC is 7 weeks, so AC is a critical path. AC is 2 plus 5 weeks equals 7 weeks. All right, so that's the first scenario. And then we have the second scenario. So A is done after 2 weeks, B done after 6 weeks, C done after 5 weeks, right? And the probability here is 0.3. All the scenarios, we need to add up to 100%, right? So 0.7 plus 0.3 is 100%. So one more time, we need to look at the project with the new data. So we have A, right? A goes to B, and then A goes to C. And the completion time is 2 weeks for A, B is 6 weeks, C is 5 weeks. So again, we need to find the completion time of this particular scenario 2 project, right? So to find the completion time of that project, we need to find the critical path. I would like to ask the whole class, which one is a critical path for the second scenario? Okay, so yeah, I have some answers from many students already. Good, you are all correct. That's good. Right, Harlan, Christopher, Alita, Jose. Yeah, you agree, and you're all correct. That is correct. So the critical path here is the CP, the second scenario critical path, okay? The number 2 here is the critical path of the second scenario. It's going to be AB because it is a longer between the two possible pathways through the project. So AB is 2 plus 6 equals 8 weeks, right? So with time uncertainty, the critical path might switch among different pathways. So in this case, right, this is our critical path. Okay, so if the first scenario happens, it takes us 7 weeks to complete the project as earliest. I say earliest because if we delay something, we might delay the project, right? So as earliest, we can complete the project in 7 weeks. In the second scenario, it's going to take us 8 weeks to complete the project. So we need to calculate the average between 7 weeks and 8 weeks, right? And here is how we do it. So this is our expected completion time of the project. So to do that, we take the 7 weeks in the first scenario times with the probability of 0.7, right? And then plus the 8 weeks in the second scenario times with the probability of 3.3 for the 8 weeks, right? So the probability of the weeks for us to calculate the average, where the average is somewhere in between. So next, right, the first term is 4.9 weeks. The second term is 2.4 weeks. So the final answer here is 7.3 weeks, right? So on average, it's going to take us 7.3 weeks to finish the project. So that's what it means, right? Sometime it means that sometime in the reality we finish the project after 7 weeks. Another time we might finish it after 8 weeks, but on average we have about 7.3 weeks. So if I ask you this question in the project, I mean in the final exam, do you think it is okay or not? I hope it is okay if we have to do this in the exam, right? All right. So for that, I would like you to get prepared. All right. Thank you for the feedback. So also Jose. Okay, good. So so to prepare for this question in the final exam, I give you question 26 in the homework 3, right? So in question 26 of homework 3, instead of only 2 scenarios, I give you 3 scenarios. Hopefully it's not too much. 2 and 3, they are kind of the same, right? And I would like to remind everybody that I already posted the study guide for the final exam, right? I list all of the topics that that I might test you in the final exam. So just review topic by topic, and hopefully you are clear. And if you have any question, please feel free to ask. But you know what? Our exam will be on Monday, so it's very early, right? That's the Monday in the final exam week, so we gotta start everything as early as possible. Okay, so now we are done with this topic, and this is the last topic of module 7, right? And then we would move on to module 8 right away. So again, in module 7, we talk about the definition of the project. We talk about the project management. We talk about the critical path method. and then how to crash a project, and finally a project with time uncertainty, right? So these are the main topics of Module 7. So for Module 8, I would like to share with you the PowerPoint as a following. So Module 8 is about supply chain management, right? It's a very trendy keyword that we hear a lot nowadays because of all the disruption, right, in retails, in manufacturing. Okay, so we have here Module 8 about supply chain management, and it is mainly based on chapter 11 in our textbook. But of course, I always try to include the topics from outside so that we can learn more. As a heads up or the overview from now on until the end of the semester, I would like you to focus on these 5 modules here, right? We are done. We are done with the first 7, and ahead of us we have 5 modules. That sounds like too many topics, right? Of course, but then the nature of these are the following. All of these topics are belonging to the supply chain management, right? So supply chain management is an overview. Within it, we have inventory management, right? So we learn inventory management as part of the supply chain management. And then in inventory management, we're going to learn about 3 important models that managers would normally use to manage their inventories, right? So we're going to learn about one model in Module 10, another model in Module 11, another model in Module 12, right? So these are the 3 important models that managers will have to use to manage their inventory. All right. So let's talk about Module 8. It is an overview of the supply chain and supply chain management. So what is a supply chain? A supply chain is a network of processes and facilities, beginning with raw materials and ending with final users, right? Like this. Sometimes we have the other way around. We call it as a reverse logistics. So what do we have in a supply chain? So that's a supply chain structure. For example, the supply chains of cars, the supply chain of toothpaste, things like that, right? Then it's not straightforward. Generally, it is composed of multiple players, multiple companies inside that supply chain, right? In this particular graphical example, we have multiple tier suppliers. They will supply their products to the tier 1 suppliers. And then the tier 1 suppliers will ship the parts, components, and assemblies to the manufacturers, like the car manufacturers, right? And then after that, after the manufacturers, we have the distributors. And then after the distributors, we have the retailers, right? So that's the one example of how a supply chain might look like, right? It's not as straightforward as a line like this. It is how to say, it is a mosaic of many companies, of many parts in it that supply to the supply chain, right? All right, so I would like to go to the whiteboard to organize our discussion. Okay, so today we move on to Module 8 about supply chain management, or SCM. It's a very trendy keyword nowadays. Right, so first of all, what is a supply chain? The supply chain is a network of processes and facilities right? What are the processes? For example, the mining process. You extract the materials, the minerals from the nature, right? Or we need to gather the crops, things like that. So the mining process, the gathering process, and then we need to manufacture something, manufacturing processes, and then distribution processes, retailing processes, online operation processes, right? Or facilities. It can be the mines themselves, the factories, the fields, the gardens, the warehouses, the fulfillment centers, the online operation centers, right? All of these are part of the network. And remember, they start with raw materials and end with sorry, and ending with final users, right? So to make it easier for you to imagine what a supply chain looks like, I would like to give you a very simple draw. So we have the supply chain as a pipe like this, right, where things will flow through. So in our supply chain, we will have processes and facilities. Right, so that we, at the beginning end, we can take in the raw materials. And at the end, we ship the goods to the final user. It can be the services too. At the end, we deliver the services to the customers, right? Okay, so a supply chain is like that. It might span over many countries. It span over uh, many companies. It doesn't have to be just one, right? So that's the concept of a supply chain. It can be both ways. It can be going forward. It can be going backward. The backward, for example, sometimes we have to take back the unused medicines, right? We don't want to put the antibiotics onto the water or soil, because at the end we're going to eat them, right? It's not good for health. So sometimes we have the so-called reverse logistics. Okay, so that's a supply chain. And the next thing is I would like to talk about the supply chain structure. So who are the key players in a supply chain, right? The suppliers will bring us the natural ingredients or parts and components, right, for our manufacturing processes. So first of all, we're the suppliers, and normally we might have tier 3 that supply to tier 2, and then supply to tier 1, right? And then the tier 1 will supply the parts and components to the manufacturer. All right. So we have the manufacturers right here. And after the manufacturers are done with the goods, they will ship they will distribute it through the distributors. And then the distributors will transfer the goods to the retailers. Right? So that's the general structure of the supply chain. But of course, we look at the picture earlier, right? The supply chain can be very complicated because they have multiple suppliers, multiple layers of suppliers, multiple manufacturers, multiple distributors, and multiple retailers. All right, so again, I would like to refer you back to the figure in module 8, slide 6. All right. Okay, so next, I would like to talk about the performance metrics. So as a supply chain manager, what are the numbers? What are the metrics that we need to keep track of so that we can manage our operations, right? Then the first group of metrics is called cost metrics. For example, if we talk about how much it costs us to source a good, right? So it is an item cost. And then the labor cost, right? We'll look at the labor cost so that we will know how to move the workers around, things like that, so that we can use the services the most efficiently, right? And then transportation costs, and then inventory holding costs. All these are important because if we do not control the cost will cut into our profit, right? Literally, our stock price might go down because the reported profit margin goes down. So that's the cost metric. And then the second group is called the service metrics. These are also important to our operations. For example, the lead time. It is the lead time is a time gap between the order point and the receipt point. For example, if we go to Amazon.com and buy something, and then you receive the goods after 2 days, right? Then the lead time of Amazon.com is 2 days. We're going to talk about lead time a lot later on. And then another important concept is called the in-stock probability. What is a percentage of times that we have enough stock to sell? If the in-stock probability is low, then we might forego many sales opportunities, right? That's not good. So we have to actually manage the in-stock probability. Together with the in-stock probability, we have the stock out probability. It is in stock, 1 minute in stock. Right, because in stock and out, stock out adds up to 100%. So if we know one, then we just do 1 minute at the other one. Right, so the lead time, the in stock probabilities, or stock out probabilities. are the one that we talk about most later on. Besides, there's another service metrics is called fuel rate. Right. So if the customers order this much, how much you can fill? So right. So that's the cost metrics and the service metrics that managers will have to keep close monitoring on, so that he or she can make the right decision. Okay, so that's the performance metrics. And next, I would like to talk about the supply chain decision. Oh, there is one thing. I'm sorry, I forgot. The next topic that I would like to talk about is the sources. Variability. Variability means disruption or changes, right? As a manager, we don't want that at all, but we live in a world of changes, ever changes. So we have to know ahead of time what can be the sources of changes, right? The first source of variability here is the demand itself. The first aspect is the level, right? Sometimes the customer wants to buy a lot of these because it is a holiday season or something like that. But after that, they will not buy much, right? So the level of demand will change in the year. And then the second is the variability in terms of the location, right? Might be the residents around one store buy a lot of one item, but the residents in another store buy very little of that item, right? So we might have a stock out in one store, but we still have the services in another store. So that's the location variability, right? And then another dimension of the demand is the variety. Sometimes we have the changes or the variation in the variety. People want different clothes with different sizes, with different colors, with different styles, right? So sometimes they want this, another time they want another style. So that's the changes that the managers want to take care of. So that's from the demand itself. Another source of variability is called the bullwhip effect. So the bullwhip effect is actually the exaggeration of the demand variability over the supply chain. To see that, I would like to draw the following picture. Can I illustrate it? Okay, so let's draw the supply chain in the reverse order. In this case, I would or draw the customers first, right? So every day they buy something, and they do not buy the same amount every day, right? So the demand amount is fluctuating, and that fluctuation in the demand is signal to the retailers, because the customers buy directly from the retailers. And then at their turn, the retailers will send the signals to the distributors. And then the distributors will send the demand signal to the manufacturers. Right? So between the customers and the retailers, the customer might send the varying demand signal like this. Sometimes they buy more, sometimes they buy less, right? But then when the retailers see these variation, normally they overreact. They do not really know the actual demand, right? So sometimes they buy a lot, sometimes they buy a little. So the signal that the retailers send to the distributors, right, varies more than the original signal. And then the distributors, when they send the demand signal to the manufacturers, then what the manufacturers see is a very wild, fluctuating demand signal, right? So you see that this is called the bullwhip effect because from a very small source of variation, now we see more and more variation along the supply chain, right? Okay, so it's like the bullwhip because we only swing the handle a little, not too much, but then the end of the rope, right, travels very far and wide. It's like the handle that we are holding here, and the end of the rope is right here, right? It fluctuates. It fluctuates a lot. So the bullwhip effect is what? It is the exaggeration of the level of variability in the demand. And normally the bullwhip effect happens because of the overreaction along the supply chain, right? Okay, so that's the second source of variability. The next source of variability is called partner's performance. For example, we would like to see how available the products are. We ask our partners, do you have goods available for us or not, right? Or do you have not only sourcing is about using transportation too. So you ask your partner, do you have the truck to carry our goods or not? To ship them to the stores or not? Things like that, right? So it's about availability. Then another one is responsiveness. We order something from our suppliers. Do they have how fast can they respond to our order, right? Is that 5 days? Is that 1 week, or something like that? That's the speed of responsiveness. And then another dimension that we look at our partner is are they reliable or not? For example, they say that they can deliver the goods after 1 week. Is that true, or will they do that after 2 or 3 weeks, right? So that is reliability. All right. So another source of variation is coming from all other factors. Right? The disruptions here can either be like social, like political. Right? Social and political disruption happened a lot during the early the pandemic, right? And then you know what? Sometimes we also have to deal with the natural disruption too. For example, we have to deal with the wildfires, right? In California, earlier we have a no fire season and a fire season, but now the whole year is a fire season, right? Fires can happen at any time. If it is a hot day, if it is a windy day, if it is a dry day, fire might happen, right? So another thing that California will have to deal with a lot is the earthquakes, right? Every day we have the trembles in the ground. Maybe they are small that we do not realize, but sometimes we have a big quake, right? Or everybody is waiting for the big one. The big one is the giant earthquake that affects the whole California. So as a manager, right, we have to think ahead of time what to do to mitigate the impact of the earthquake disruption or any other earthquakes or any other disruption. Um, Another, you know what, in the natural disruption here, please don't forget that we are still in the pandemics. That caused a lot of disruption, right? So, and again, as a manager, right, we have to think ahead of time so that we can kind of isolate ourselves or at least mitigate the impact of the disruption. Okay, so you know what, in the reality that we see nowadays, we see a lot of disruption in the supply chains, right? It happens in many forms. It happens many reasons. All of the reasons can be traced back to the list that we have here, right? So the supply chain, the disruption to the supply chain, right, will impact the supply of the goods that we order. At the same time, nowadays it seems that people order more because a lot of things happening online, right? People can easily find the products that they want. They just order it, and then for a short period of time, they receive the goods. So because of that, they might order more through the online things, right? And then because the government keep the interest rate low, and then they spend more, right? So all of that will boost up the demand. So again, we have a disruption in the supply side. We have more demand, and might be because of that we have the inflation pressure, right? Because when we have more demand and the supply side cannot catch up with it, then we will have the inflation pressure. Hopefully, it's not because of the money. It's just because of the real demand that that we have more than before. And hopefully, on the supply side, they can straighten out the disruption, right? So that they can supply more. Okay, so that's another big topic of the sources of variability. Right? As a manager, you need to be aware, to be conscious about these possible disruptions to plan ahead. So in the next topic, I would like to talk about the decision of supply chain. Supply chain decision. We can classify all the supply chain decisions into two big groups. In the first group, we have the tactical decision. And in the second group, we have the strategic decision. Right? In the tactical decisions, for example, what do we carry for this holiday season, right? What to carry, and then how much that we should carry for this Christmas season, and then when to order them, when to bring the stock to the fulfillment centers and to the retailer stores, or for the online operation to be ready, right? So what, how much, and when? All of these are kind of short-term questions, and we call them as a tactical decision. In strategic decisions, right, the decisions are bigger. and only it is for the medium and the long term. For example, we will talk about the product types that we try to sell, and supply chain types. For example, do we try to sell it online alone, or brick and mortar store alone, or do we do the hybrid between online and brick and mortar stores, right? And then another important decision is the modes of transportation. And another important topic here in strategic decision is, do we produce it or do we outsource it? Do we produce it or do we hire another company to do it for us? Right. All right. So let me. So that's the focus of the remainder of this module 8. We're going to focus on that, producing or outsourcing question. So, do we produce it or do we outsource it? Before I show you the example, let me discuss this very briefly. In this context, right, producing has another name as vertical integration. So what does that mean, vertical integration? For example, we have the supply chain, and we are part of the supply chain, then we are here. Like Apple, like Tesla, right? They are part of the supply chain where they mainly manufacture something. As an example, let me draw this picture. And then if we try to control more in front of us towards the raw materials, then we call this as a backward integration. Which means that we try to have more control with the supplying processes, right? For example, Tesla, they do that when they produce the batteries by themselves, right? They do not source it from another company. They produce batteries by themselves. So it is called backward integration because they will have more grip or more control on the battery supplying process. Or some companies, they also do it in the forward way, so towards the final users. We call this as a forward integration. Right. For example, Apple. They manufacture the devices, and normally other companies will distribute that for them and sell that for them, right? But they set up their own retail store so that they can directly access the customers, right? So in that sense, right, they have more control forward. So vertical integration is about having control, right? We integrate more the parts before our manufacturing process, or we integrate or control more of the processes after manufacturing. So we have vertical integration, means that we have more control along the line of the supply chain like this. In opposite, producing, we have outsourcing. Outsourcing means that we replace the internal processes with the third-party company processes. But instead of producing it by ourselves, then we ask another company to produce it for us, right? So in a sense, we replace our manufacturing process by the manufacturing process of another company. Manufacturing or services like logistics, right? Wrapping the boxes and shipping the boxes out. Some companies, they hire another company to do it like that. All right, so here we have the question, the big question. So when do we produce and when do we outsource, right? The answer to this question is all about cost analysis. So the main idea here is if it is cheaper to produce, then we produce the product in-house. And if it is cheaper to outsource, then we're gonna hire another company to do it for us, right? So that we can save money. We need the same quantity. Either we produce it in-house or we outsource it to another company. When we say another company, it doesn't have to be in another country. Another company here is just another process that will replace our own process. Of course, a lot of the time we outsource it to another country, but it is not necessary to outsource to another country. So I would like to show you the example for this producing or outsourcing topic. We will not have time to cover it, the example. So at the end of the day, I will add the notes to guide you through the example, right? Together with the class notes that we already have here. So let me share with you the example. It's easy, it's not that difficult. All right, so we have this in module 8. If you go to module 8, you should see this PDF file. A US motorcycle manufacturer has the option of either making the gas tank in their newly designed motorcycle or subcontracting it to a manufacturer from Singapore, right? So let's think about this as Harley-Davidson. They newly designed motorcycle. And they plan to sell 1,000 bikes each year, right? So each year they will need 1,000 gas tank to put on the bikes, right? So that's the context here. So either Harley-Davidson will produce a gas tank by themselves, or they will hire another company to do the gas tank for them, right? So the cost for the two options are, if they make the gas tank in-house, they first of all will have to set up the workshop, right? And that costs them $15,000. And for each gas tank that they produce, is going to cost them $21.5, right? So for the in-house option, they will have the make in-house option. They will have to spend the fixed cost of $15,000, and for each gas tank, they will have to spend $21.5. In the second option, they will hire another company to manufacture the gas tank, and then they buy it from them, right? So they don't have to set up the shop anymore. So in here, we assume that the fixed cost is zero, right? In the reality, maybe the fixed cost is not zero because, for example, they will have to hire a law firm to sign to come up with the contract, right? That is costly. So the fixed cost in that case is not zero. But in this case, we assume that it is zero. So the fixed cost is zero and the variable cost is $29 per gas tank, right? So we need to compare between the two and see which option is better. So in part A, we write out the total cost of production. In part B, we write out the total cost of outsourcing. And then we calculate the total cost of production and outsourcing with the quantity of 1,000 gas tank, right? And in D, we look at the answer in C and see which one is a better option. If the total cost of production is smaller than outsourcing, then we choose producing. But if the total cost of outsourcing is smaller, then we're going to choose outsourcing, right? So the bottom line is we look at the cost and try to minimize the cost that we have to spend so that we have a wider profit margin, right? So in part E, we need to draw a graph to illustrate the situation and then find the break-even point. The break-even point is the quantity of the gas tank, right? At which the total cost of producing and outsourcing are equal. We call that as a break-even point. And then would the decision be different if the quantity changes, right? Relative to D, if the quantity of gas tank changes, then would we change our decision? So it might be a long question here, but actually the calculation, the interpretation is quite easy, right? Let me point you to one slide in the PowerPoint where we have the equation. Slide 20th in the PowerPoint. Okay, so we know the quantity that we need to sell. We know the fixed cost of production. We know the variable cost of production. We have the fixed cost of outsourcing, the variable cost of outsourcing. Then the total cost of production is this, right? We add the fixed cost with the variable cost. The outsourcing also the fixed cost with the variable cost. And then we're gonna choose outsourcing if it is cheaper. And if it is the other way around, if producing is cheaper, then we're gonna choose producing, right? In-house production. And that is the equation for the break-even point, right? So I will add the guide through this example in the class note, and you're gonna see that soon. So I would like to thank you all for joining me. I hope you will attend the class on Wednesday, right? Hopefully, because you do not have to drive home, so you can still attend the class on Wednesday. So have a good rest of your day, and see you back on Wednesday.